Alright, so let's have a look at some of these questions. So for question 1, we just have to simplify each expression. Okay, so the first question there, question 1, we've got 4a minus 3 minus 2 times 3 minus 2a. Okay, so the important thing we're testing here is just, do we know how to multiply out brackets? So the first 4a minus 3, we can just rewrite that as 4a minus 3. Then we have to multiply the negative 2 into this bracket. So negative 2 times 3 is negative 6, and negative 2 times negative 2a will be positive 4a. And then we just collect our like terms, so 4a plus 4a, that's 8a, and negative 3 minus 6 is negative 9. And that's our answer. Let's underline that. So that is our answer. Then the second question, I'm just going to go through these. Whenever you feel like you've got a different way of approaching the question, or you tried something else, let me know in the comments below, and we can have a discussion about that. Second question: negative 2x times x minus 5 plus 3x squared. Okay, it's the same idea. Multiply the negative 2x into the bracket. So negative 2x times x is negative 2x squared. Then negative 2x times negative 5 is positive 10x. And then we add the plus 3x squared at the end. Collect our like terms. So we've got negative 2x squared plus 3x squared. That gives us positive 1x squared. And then plus 10x. Okay, and that's our answer. So a fairly straightforward first tutorial here. Just recapping on some of the basics from high school. Third question, we've got x over 1 minus x. Minus, and then x squared over 1 minus x squared. So x squared over 1 minus x all squared. Alright, so here we want to find a common denominator. So we definitely want to use the first fraction's denominator. I always start with the first fraction. So we've definitely got that. Then we look at the second fraction. There we have two of these things. So we need to add another one. Okay, so we need to add another one. So we've got two of them. This fraction had an x at the top, so what does it still need? Well, the fraction needs two 1 minus x's, so this fraction still needs another 1 minus x. Right, it already has a single 1 minus x, it still needs another one. Minus, okay, there was an x squared. This fraction already has everything it needs, so the top doesn't need to be multiplied with anything. Okay, then we just multiply in the bracket, so x times 1 is x. X times negative x is negative x squared, and then we add our negative x squared at the end. All of this is still over 1 minus x squared, and then we just collect our like terms. So negative x squared minus x squared is negative 2x squared, and then we add our x. And at the bottom, let me actually, just for this question, I'm going to rewrite it just keeping the x first. So x, and then minus x squared minus another x squared is minus 2x squared. I also assume that's what most of you would have done in that order. And just so that the next step makes a little bit more sense, or is at least a bit easier to see, although it doesn't matter. Okay, here at the top we can factor out an x, common factor of x. What's left is 1 minus 2x. Okay, over 1 minus x squared. Okay, and that's it. There's nothing else we can do here. So that is simplified. Let me just make sure I didn't make any mistakes here. The x minus x squared, and then minus another x squared. Yeah, no, that looks fine. Okay, that was the third question. Then the fourth question, we have negative 18 over 3a. The negative 18 over 3a times 12 over 36 ab times 12 over 36 ab. Okay, so here we can just start off by multiplying straight away. What I want to do is I'd like to simplify things first as far as I can. So negative 18 over 3, we can simplify this to just be negative 6, right? And then 12 over 36 we could simplify to be 1 over 3 AB. Okay, And now let's multiply. Negative 6 times 1 over 3 is negative 2. A times A is A squared. And then there's also a B. And that's it. There's our answer. I should have probably underlined this one as well. That's our answer. Good. Fifth question. You see, it's fairly straightforward, these first couple of ones, but it's good to get into the groove of just remembering how some of these things work if you haven't done that in a while. Okay, 35x to the power negative 6. 35x to the power negative 6 over, what is that, 14x to the power 4. Over 14x to the power 4. Alright, so 35 and 14, I don't think there's, oh, there's 7. Both of them can be divided by 7, so we can simplify that. So that becomes 5 over 2. And then the x's. So we can take, we don't want negative exponents, so let's take them to the bottom. So at the bottom we've got x to the power 4. And you don't need to do this extra step that I'm doing now. It's just to show how it works. So in this one, to make this exponent positive, we can take that to the other side of the line. And then that becomes x to the power positive 6. So you just change the sign of the exponent if you take it to the other side of the fraction line. And then we want to remember in school, if our bases are the same, so both of them are x's, and we're multiplying them, then we add the exponents. So the exponents are 4 and 6, we add them, we get 10. And that's our answer. That's it. Alright, sixth question. Let's move up again to here. The sixth question, we have negative 2a to the power negative 2, all to the power negative 2. Lots of negative 2's in here. Okay, so what else we can remember from school is this exponent here. If everything is multiplied inside, you just multiply this with all the exponents inside. So negative 2 is to the power 1. So we're going to say that's negative 2 to the power 1 times negative 2 is negative 2. Then we've got a to the power, so negative 2 times negative 2 is positive 4. Okay, so negative 2 to the power negative 2. So we can take that to the other side of the line. Again, I'm doing lots of steps here. You don't need to do all these steps. Some of you can probably just see the answer straight from the bat. So if we take this to the bottom, then the sign of the exponent changes. So instead of negative 2, it becomes positive 2. And then negative 2 squared becomes positive 4. And that's it. Alright, question 7. Question 7. Here we have, well, that's a bit of a longer one. 1 over 16. A to the power negative 4. B to the power 2. Times 2 to the power 3. A to the power 4. B to the power negative 1. Okay, so this is just all multiply. So we can just multiply. So 1 over 16 times 2 to the power 3. So 2 to the power 3 is 8. So 8 times 1 over 16 is 8 over 16, which we can simplify to 1 over 2. Okay, then we've got the a's. So negative 4 is multiplying, so we add the exponents. So negative 4 plus 4 is 0. And then the b's. 2 plus negative 1 is 1. So that just gives us 1 over 2b. Because anything to the power 0 is 1. And that's it. And then the 8th question. Question number 8. Here we've got negative 27, x to the power 5, y to the power negative 2, over 9, x squared, y to the power negative 5. And all of this raised to the power 4. Alright, so again, you can, if you want to, you can first multiply the 4 in as an exponent with everything. What I like to do is simplify first inside the bracket if I can. So I'm going to do that. So inside the bracket, we've got negative 27 over 9. So that's going to be negative 3. Then we've got x to the power 5 minus 2. If we divide, then we subtract the exponent. So 5 minus 2 is 3. And then we've also got y to the power negative 2 minus negative 5. So negative 2 minus negative 5 becomes negative 2 plus 5. And negative 2 plus 5 is 3. So all of that raised to the power 4. And then we just say negative 3 to the power 4, which is negative 81. or positive 81, sorry, positive 81, x to the power 3 times 4 is 12, and y to the power 3 times 4 is also 12. And there we have it. So that is question 1. Okay, let's move on to the next page for question 2. Okay, so for question 2, we're asked to simplify each of the following, assuming that all bases are non-zero real numbers and all exponents are integers. Okay, so not much to know here. There's not too much going on here. This is just, if we don't assume this, we can get into some trouble at some stage, but that's usually actually beyond the scope of what we need to do here. So this will be true for all the things we want to do in this course. Okay, so question 2, first question. We've got x to the power 2 minus n, all raised to the power 3, times x to the power n minus 4, all raised to the power 2. Okay, so we apply the same logic as in the previous couple of questions. So for this one, now we multiply this with this. We multiply the exponents, right? So 3 times 2 is 6, 3 times negative n is negative 3n. Multiplied by x to the power, 2 times n is 2n, and 2 times negative 4 is negative 8. Now again, we're busy multiplying, so what do? We add the exponents. So 6 plus negative 8 is negative 2, and then negative 3n plus 2n is negative n. And there's our answer. Simple. So we just apply our laws of exponents, multiply the exponents when you're raising something to a power, and then when you're multiplying, you just add the exponents. And that's it. Second question for question 2. We've got here y to the power negative 1 raised to the power m minus 3. Then we've got y to the power 3 raised to the power 1 minus m. 1 minus 2m, sorry. I'm lying to you. 1 minus 2m. Alright, same idea. So we've got y, multiply the exponents. So negative 1 times m minus 3 gives us negative m plus 3. And then the other y, multiply 3 with 1 minus m, so that gives us 3 minus 6m. And now again, we're multiplying the y's, so then we add the exponents. So negative m plus negative 6m is negative 7m. And then 3 plus 3 is 6. And there's our answer. Easy. Okay, third question. Here we have 14 u to the power 3m, v to the power 8n, over negative 35, u to the power 6m, and v to the power 5n. Okay, so let's simplify. 14 and 35, we had that earlier. Where was that? 35 and 14, just the other way around. Okay, so we can divide both of them by 7. So we'll get, if we divide both of this by 7, we get 2 and negative 5. And then for the u's, we can have u to the power negative 3n at the top, but to keep it positive, I'll just have the 3m at the bottom. Right, because we've got 6m minus the 3m is 3m at the bottom. Okay, and then for the v's, the bigger one is at the top, so I'm going to keep that at the top. And then 8n's minus 5n's is 3n's. But this is exactly the same as if you were to say negative 2 over 5, and you, let's say, wanted to keep everything at the top. You could have u to the power negative 3m and v to the power 3n at the top. That's exactly the same thing. So if you got that, no worries. And you could also have this negative sign here, could be at the bottom, could be at the top, or it could even be just next to the sign. Makes no difference. All of that's exactly the same thing. Alright, let's move on to question 4, or this fourth part of question 2. The last one here. So here we've got x to the power 2 minus 3n times y to the power negative 8. So let's do the fraction line first. Over x to the power 1 minus 4n, and then y to the power negative 6. And all of this whole fraction is raised to the power negative 2. So again, lots of things we can do first. What I'd like to do first again is simplify inside the bracket. So let's do the x's first. So we've got x, and now we say that this exponent minus this exponent, because we're dividing, right? So let me just write it out this time. So 2 minus 3n minus the bottom exponents, which is 1 minus 4n. Right? So we take the top exponent minus the bottom exponent. And then we do the same for the y's. Take the top exponent minus the bottom exponent. And all of this is still raised to the power negative 2. Okay, so now we have our x. So let's do just simplify this. So we've got 2 minus 1, which is 1. And then we've got negative 3n minus minus 4n. So negative 3n plus 4n is plus n. Okay, and then for the y's we can do the same. So negative 8 minus minus becomes plus. Negative 8 plus 6 is negative 2. All of this is still to the power negative 2. And now let's multiply our negative 2 with the exponents. So this times negative 2 will become negative 2 minus 2n. And then with the y's, negative 2 times negative 2 is 4. And that's our answer. And again, you could also decide you want to take the x's to the bottom if you don't like the minuses at the top, and that's still fine. But because it's a variable, it doesn't really matter if it's positive or negative. If it was just a number, like if it was y to the power negative 4, then we would want to take the y to the bottom to change its exponent. But since there are variables in here, it doesn't matter if it's negative when there are variables, because the variable itself could be negative, which turns this into a positive again. Alright, so that's fine exactly like that. Alright, so that was question 2. Let's do question 3. Expand the following and simplify. Okay, so that's just multiplying out brackets again. So question 3a, we've got 2u squared plus 3v times 3u minus 2v squared. 3u minus 2v squared. So how do we multiply? Let's move this down a little bit. Oops. Okay, that should be fine. Alright, so multiplying this out, multiply everything in the one bracket with everything in the other bracket. So this first term, multiply with the first term, then with the second term, etc. But we'll see as we go along. So 2u squared times 3u will give us 6u to the power 3. Then we multiply this first term with the other term in the other bracket. So 2u squared times negative 2v squared equals negative 4u squared v squared. And then we take the second term in the first bracket and multiply it with everything in the other bracket. So 3v times 3u is 9uv. And then those two, 3v times negative 2v squared. That gives us negative 6v to the power 3. And now we check, are there any like terms we can collect? If there are, we should. And in this case, there are none. Right? The like term is like terms are terms that have exactly the same letters with the same exponents. So here we've got a u cubed, nothing else is just a u cubed. U squared, v squared, nothing else has a u squared and a v squared, etc. So that's how you know things are like terms. So in this case, that is our final answer. Simplified. Question B. Here we have, what is that? Square root of 2 minus square root of 6. Square root of 2 minus square root of 6 squared. Okay, so let's do this the long way, because let me just show you what some people do here, which is wrong. A very common mistake. So this is not equal to. You can't just take this square inside. So you cannot just do that. If you do that, you'll get something like square root of 2 squared minus square root of 6 squared, which will give you 2 minus 6, something like negative 4. So if you got this, common mistake, right? Or even something like 2 plus 6, because of the negative being squared, equals 8. This is a common mistake. This is not correct. Okay, so let's see why. Let's see why that's a mistake. Because what does square mean? Square means multiply by itself. So we've got this bracket, square root 2 minus square root 6, times square root 2 minus square root 6, because the whole bracket is being squared, not each individual part. Very important. Okay, so now we just apply the same multiplying out as we did for question A. So square root 2 times square root 2, that is just 2. Square root 2 times negative square root 6, that's negative square root 2 times square root 6. And we'll see in the next step, again, you can combine these two. When you're multiplying or dividing square roots, you can just have a single square root and multiply or divide the numbers. So we'll do that in the next step. I'm just showing what we're multiplying here. Okay, then we've got negative square root 6 times square root 2. So negative square root 6 times square root 2. And again, the order doesn't matter here. It's the same thing. A times B is the same as B times A. So these two things will be the same. And then we've got negative square root 6 times negative square root 6. It's going to be positive square root 6 squared, so just positive 6. Okay, so we can say 2 plus 6 is 8. We'll simplify that. And then we've got two of these things, right? So we've got 2 square root 2 square root 6s that we're subtracting. But we can simplify this a bit further, because square root 2 times square root 6 we can simplify as square root of 12. But again, square root of 12, so let's just do this. So 12, and if you type square root 12 in your calculator, you'll get 2 square root 3, right? But let's see how we get there. So I suppose, you can just do this in the calculator and that should be fine. But to be able to see how we get this, we first take the prime factors. So 12 is the same as 2 squared times 3. And now what can we do here? Since here is a 2 for a square root, how many 2 squareds do we have? We've got a single 2 squared. So we can take out one of them. And then how many 3 squareds do we have? Nothing. So that 3 just remains inside. I know I didn't explain this very well now, but okay, let me do this as an example. Let's say we've got the 5th root here. And we've got 2 to the power 11 and 3 to the power 20. If we want to simplify this, then we can say, so 5 goes into 11 how many times? Twice, right? But then there's 1 left, so there's a 2 left. Then we check, so all the 2's are sorted. Then the 3, so 5 goes into 20 4 times, so we can take out 4 of those. And how many 3's are left? None. So this will be the simplified version of this. So that's what we do at the top here. If you ever want to try and simplify without a calculator, so you'll get 2 square root 3 for square root 12. Right, so square root 12 is the same as 2 square root 3. And that then gives us 8 minus 2 times 2 is 4. So 8 minus 4 square root 3. And that, I think, is probably the simplest we can write it. Or we can factorize out of 4 and be left with 2 minus root 3. So either of these should be fine for a simplest form. Yeah, let me know what your calculator gives you if you type this in. Probably, I'm guessing this one. If you just type this whole thing in your calculator and you don't do the decimal thing. Okay, that was question B, 3B. Let's look at 3C. So here we've got 2, so let me just write it a little bit better. 2 plus, where am I now? 2 plus root 3 and 3 minus, okay, 2 plus root 3, and the other bracket 3 minus 2 root 3. Okay, again, we just multiply out. Okay, so 2 times 3, 6. 2 times negative 2 root 3 is negative 4 root 3. And root 3 times 3 is plus 3 root 3. And root 3 times negative 2 root 3 is going to be negative 2. And root 3 times root 3 is 3. Right, square root of 3 times square root of 3 is 3. Okay, so we've got 6 minus 6, so these two cancel out. And then we've got negative 4 square root 3 plus 3 square root 3. So negative 4 plus 3 is negative 1 square root 3. Okay. And again, yeah, this is probably what your calculator will also give you if you do that. So that, yeah, that looks like that's the answer. Let me just do our answer lines here. So that one or that one in the previous case. This one should be fine. Then question 3D. We've got 2a squared minus b squared. Oh, a triple thing. 2a squared minus b squared plus 3ab times, then ab squared plus, no, minus 3a squared b plus b squared. Okay, so this is just nothing difficult here. It's just a long and ugly one. because now it's the same process as over here, but we'll just have lots more lines, because everything here, each term in this bracket has to be multiplied with all the terms in the other bracket. Okay, let's get started. So first, this. So that's going to be 2a cubed b squared. Then we do that one. So 2 times negative 3, negative 6, a to the power 4, b. And then we do that one. So 2a squared b squared. Okay, so the 2a squared is that. That part is that. Yeah, so let's do this. So negative b squared times this first term, so we get negative ab to the power 4. Then negative b with the next term, so it's going to be positive 3a squared b to the power 3. And last term for the negative b, so the last one, so negative b squared times b squared is negative b to the power 4. Okay, and then we have our last, this 3ab part. So 3ab times ab squared, that's going to be 3a squared b to the power 3. Then 3ab times negative 3a squared b, so that's going to be negative 9 a to the power 3b squared, a to the power 3b squared, and finally 3ab times b squared is going to be 3ab to the power 3. 3ab to the power 3. Okay, now we look for like terms. So a to the power 3b squared. Let's look for any other ones of that. A to the power 3b squared here. Okay, so we've got that one and that one. They are like terms. So 2 minus 9 is negative 7. A to the power 3b squared. Okay, a to the power 4s, this is the only one here, so minus 6a to the power 4b, that's the only one of those. Then a squared b squared, this is the only a squared b squared, so we've got 2a squared b squared. Then ab to the power 4, that is the only ab to the power 4, so minus ab to the power 4. Then a squared b to the power 3. Okay, so here we've got one of those, and here we've got another one of those. A squared b to the power 3. So 3 plus 3 is 6 of those. 6a squared b to the power 3s. Then we've got negative b to the power 4, that's the only one, and 3ab cubed. Plus 3ab cubed. Okay, and that is then simplified. So you see, it's just an ugly, messy one, but nothing difficult here. Just apply the same idea. Take every term and multiply it with every term in the other bracket, and then you collect your like terms, and that's it. Okay, that was number D, and then E. Okay, so E, we've got 2 plus A. So 2 plus A. 3 minus A and A plus 4. 3 minus A and A plus 4. Okay, so we've got 3 different brackets. So basically what you want to do is you want to multiply any 2 brackets first and then multiply that answer with the remaining bracket. So it doesn't matter which 2 brackets you do first. I'm going to do the first 2 first. So I'm first going to do these 2. Okay, so if we multiply those 2, we get 2 times 3 is 6. 2 times negative A is negative 2A. A times 3 is 3A. And A times negative A is negative A squared. And then we still have our other bracket. Okay, so let's first simplify this bracket, see if we can collect any like terms. So minus 2a plus 3a is just plus a, and then we've got our minus a squared. A plus 4. So you don't have to first simplify, but it's obviously a lot quicker than you don't have 4 things that you have to multiply with everything. So usually if you can, you want to simplify in the bracket, that just makes your life easier. Okay, now again back to taking each term here, multiplying with all the terms in the other bracket. So 6 times a, 6a. 6 times 4, 24. Now with the a times a squared. A times 4, 4a. And then with the negative a squared. So negative a squared times a, negative a cubed. Negative a squared times 4, negative 4a squared. Okay, collect like terms. Let's start with the biggest exponents first. That's usually a good idea. So a cubed is only that one term, so it's negative a cubed. Then the a squared, so we've got a squared minus 4a squared, so that's minus 3a squared. Then the a's, so we've got 6a plus 4a, so that's 10a. And then the numbers, which is just the 24. And that's it. Done. Let's do a proper line. There we go. Okay, so that was question 3. Then question 4. Question 4. So what do we have to do here? Rationalize the denominator or numerator where possible. Okay, so we've got 2 over square root 3. So rationalizing it means the denominator has to be rationalized. So we cannot have an irrational denominator. So what can we do? Well, any expression we can multiply by 1, because that doesn't change it, right? So if we've got 3, let's say, and we want to multiply that by 1, our answer is still 3. And we can multiply by 1 in creative ways. So we can say 3 times, let's say 4 over 4. So what does that give us? So that gives us 12 over 4. That's still 3, just a different way of writing it, so we didn't change anything. So that's basically the idea. That's the that's the trick we're going to use, is multiplying by 1. Okay, so we want to multiply. What will get rid of a square root? Well, another square root if we multiply it. So we're going to multiply this by square root 3 over square root 3, because this is 1, so it doesn't change anything. So what does that give us? 2 times square root 3 is just 2 square root 3. And at the bottom, square root 3 times square root 3 is 3. And that's it. So now the denominator is no longer an irrational number, so we have done it. That's what we want to do. Question B. So basically, if you see a square root at the bottom, you want to multiply by that square root over itself. And we'll see, yeah, here we get to the next one. The conjugate trick is a very common thing in mathematics to simplify some questions. So at the bottom we've got 2 plus square root 2. So we don't want to multiply just by square root 2 over square root 2, right? So let's see what happens if we try this. So I think some people might have tried this, and you'll see it doesn't really get rid of the square roots. Because now, so we multiply the top, so we multiply that by that. So 2 times square root 2 is 2 square root 2. Negative square root 2 times square root 2 is negative 2. And then at the bottom, we multiply this. The square root 2 times 2 is 2 square root 2, and then plus 2. So we see there's still a square root at the bottom, so we didn't get rid of it. So that's why we don't want to multiply by just square root 2 over square root 2. At the top it was fine because there was just this one square root, so you get rid of it immediately by doing this. But once you have this, like 2 terms, you want to multiply by the conjugate of the bottom. What is the conjugate? Well, it's just changing the sign. So we're going to multiply by 2 minus square root 2 over 2 minus square root 2. Because this is still 1, but now life gets a bit more interesting and things work out. So we multiply this and this. Okay, so again, 2 times 2, 4. 2 times negative root 2 is negative 2 root 2. Negative root 2 times 2 is also negative 2 root 2. And then negative root 2 times negative root 2 is positive 2. Okay, so that's at the top if we multiply out. At the bottom, we get 2 times 2 is 4. 2 times negative root 2 is positive 2 root 2. And then, wait, what did sorry. I wanted to do first term here, multiply the thing. So 2 times 2 is 4, and then 2 times negative root 2 is negative 2 root 2. Then positive root 2 times 2 is positive 2 root 2. And then positive and a negative makes a negative, and then square root 2 times square root 2 is 2. Okay, again, you don't have to write all these steps. I'm just hoping that some people who are seeing this might appreciate all the extra steps in between, just in case you get lost somewhere. Okay, so 4 plus 2 is 6. Then minus 2 root 2 minus another 2 root 2 is minus 4 square root 2. At the bottom we've got 4 minus 2, which is 2. Well, these two cancel out because they're positive and negative. And then 4 minus 2 is 2. Then we can simplify it a bit further by factoring out a 2 at the top, which gives us 3 minus 2 root 2 over 2, and then the 2's can cancel. and we're just left with 3 minus 2 root 2. Alright. Okay, the nice thing about this is, I mean, it's easy to test on your calculator because calculators will always rationalize the denominator anyway. They're programmed to do that. So it's pretty nice that you can just see what your answer should be. Question C, we've got 2 root 3 minus 1 over 2 root 3 plus 1. So again, we see it's two different terms, so we want to multiply by the conjugate. So we're going to multiply by 2 root 3 minus 1 over 2 root 3 minus 1. Okay, so at the top I'm going to do this a little bit quicker. So this first term times first term is going to be 12. So if you just multiply these two, you should get 12. And then multiply this and this, so it's minus 2 root 3 minus another 2 root 3, so it's going to be minus 4 root 3. And then minus 1 times minus 1 is positive 1. At the bottom, we're going to have 12, sorry. 4 times 3 is 12. And then minus 2 root 3 plus 2 root 3 will cancel out. And then minus 1 at the bottom. So we get 12 plus 1 is 13 minus 4 root 3. And the bottom 12 minus 1 is 11. There we go. Okay, question D. Question D, we've got, looks like a bit of a longer one, but it'll be the same idea. So square root a minus 1 at the top, square root of a minus 1, and at the bottom we've got square root a minus 1 minus square root a plus 1. Okay, so square root of a minus 1 minus square root of a plus 1. So again, we're going to multiply by the conjugate of the bottom. So we're going to multiply by square root of a minus 1 plus, instead of minus, square root of a plus 1 over itself. So a minus 1 plus square root of a plus 1. Okay, so let's multiply this out. So we're multiplying this by this. So multiplying this by itself will just be a minus 1. And then plus the square root of, okay, let's do this in two steps. The square root of a minus 1 times the square root of a plus 1. All over, and if we multiply these two, so this first term times the first term will just be a minus 1. And then this one times that one, and this one times that one will cancel out. And that's pretty much, that's the reason, this cancelling out thing is the reason why we multiply by the conjugate. And then we've got a minus, and then a plus 1. Okay, let's simplify that. So the top, we can't really simplify, but we can turn this into a single bracket if we like, with the a minus 1 and the a plus 1. And yeah, I suppose that's fine. And at the bottom, we've got a minus a, which is nothing, and then negative 1 minus 1, which is negative 2. So now the denominator is rationalized. And that's it. D, we still have two questions to go here. So question E, square root of u over square root of u plus 2. So again, you guessed it, multiply by the conjugate. Square root of u minus 2 over square root of u minus 2. Okay, so square root of u times square root of u is just u. And then square root of u times negative 2 is minus 2 square root of u. At the bottom, square root u times square root u is u. So plus 2 square root u minus 2 square root u will cancel out again. And then 2 times negative 2 is negative 4. Okay, bottom is rationalized. And then number F, the last one for this worksheet tutorial. We've got square root 3 over, we've got square root 2 times square root 3 minus square root 6. Okay, so a couple of ways we can think about solving this one. And again, there's usually so many ways that we can solve anything in mathematics. It doesn't really matter, as long as what you do makes sense to you and is mathematically correct. So you're not allowed to just guess and say, it looks like that, so that's why I'm going to do it. You can do that in your homework for a while to see if it makes sense, if it helps you figure something out. But we do want to be rigorous and do something that actually works mathematically. Okay, so one thing we can do is we can first multiply in the square root 2 here. That's definitely a good option. Or we can first get rid of this square root 2 part by multiplying by square root 2 over square root 2. Let's actually do both ways. Okay, so let's do option 1 in blue. So option 1 we'll do in blue, and that will be saying multiply by square root 2 over square root 2. So that's going to be option 1. Okay, so at the top, square root 3 times square root 2 is square root 6. At the bottom, square root 2 times square root 2 is just 2. And then square root 3 minus square root 6. And now we want to multiply by, let me think. Yeah, let's just do this. So let's just multiply by the conjugate at the bottom now. So square root 3 plus square root 6 over square root 3 plus square root 6. Okay, so that's going to be at the top, square root 6 times square root 3 is going to be square root 18. And square root 6 times square root 6 is going to be 6. And at the bottom we've got our 2. Then square root 3 times square root 3 is going to be 3. And then square root 3, so plus square root 3 square root 6 minus square root 3 square root 6 cancel out. And then a minus, and then square root 6 times square root 6 is 6. So that gives us at the top square root 18 plus 6 over, and then 2 times, okay, 3 minus 6 is negative 3, so negative 3 times 2 is negative 6. Okay, and we can simplify that a bit further because square root 18, again, if we look at 18's prime factors, 18 is the same as 2 times 3 squared. So if we have the square root 18, that's the same as the square root of 2 times 3 squared, which is the same as 3 square root 2. So 18 is the same as 3 square root 2. So now we can factor out a 3 at the top. We're left with square root 2 plus 2 over negative 6. And then we can cancel the 3 and the negative 6 to give us square root 2 plus 2 over negative 2. So that is the one way. Now let's do the green way. So the green way we're going to say is when we multiply by but when we multiply this in first. That's what we said, right? Okay, so if we do that first. So the green way, so we've got square root 3 over, and then we multiply in. So square root 2 times square root 3 is square root 6, and square root 2 times square root 6 is square root 12. And then we will multiply this by the conjugate. Square root 6 plus square root 12 over square root 6 plus square root 12. Okay, so at the top, square root 3 times square root 6 is square root 18, plus, and then square root 3 times square root 12 is square root 36, over, again, square root 6 times square root 6 is going to be 6, minus, and square root 12 times square root 12 is going to be 12. So then, at the top, let's simplify both of these. So 18 is the same as 3 square root 2, and 36, square root 36 is just 6. At the bottom, 6 minus 12 is negative 6. Again, we can factor out 3 at the top, so we get square root 2 plus 2. And then negative 6, and we can cancel the 3 and the negative 6 to get square root 2 plus 2 over negative 3, negative 2. So we see we get to the same answer. It doesn't really matter which thing you do first. Both of them work out fine. Okay, I hope this was useful for the first tutorial. I'll upload all the rest of the tutorials as well as I get time. And again, if there's any questions about how we got to do some of these things, please let me know in the comments. But I do think that most of you should be fine with these basics. If you're fine with this, the next 1 or 2 will also be a breeze, and then we'll get into some of the more difficult stuff in the next few tutorials.